drill threw me off. All right, so as I was saying, the degree n can also show zeros that the graph might have. Not necessarily showing all of the zeros, because sometimes zeros we'll call them like they have multiplicity, which just means they repeat, they show up more than one time. So sometimes you might have a degree of like 6. And what that 6 means, like if it says x to the 6th power, what the 6 is telling you is that the polynomial you're working with could have at most 6 solutions out there. Now, if we look at the graph, we're looking at where does it cross the x-axis at to find solutions. But just because the graph or the polynomial says x to the 6th power doesn't necessarily mean it's going to cross 6 total times. Maybe it only crosses 4 times because some of your zeros are going to be repeated, and we'll talk about like how we write that and how we kind of approach those situations as well. Now, the degree, whether it being even or odd, can also kind of help you understand what the end behavior is going to be like. And then that kind of goes along in with your leading coefficient. So if you guys kind of look down below here, there's like all these little bullet points. Each one is kind of telling you a different combination of the leading coefficient being positive or negative, and if your degree is even or odd. So I'm just going to kind of highlight maybe some of the key words, and you guys could do that as well if you'd like to. Just so you can kind of see, like these are giving you 4 different cases. So the first one that I highlighted is saying if your leading coefficient is positive and if the degree of your polynomial is odd, your left side of your graph is going to end by going down forever, and your right side of your graph is going to end by going up forever. So if you can pull those two things, you're going to know what the end behavior looks like, and then we just have to kind of figure out what's going on in the middle. And so all of these give you different cases. So the second one is talking about if your leading coefficient is negative and if your degree is odd, the left is going to end going up, the right is going to end going down. If your leading coefficient is positive, but it's an even, the left and the right are both going to go up at the end. So they're both going to end up just going up forever. And if your leading coefficient is negative and it's even, it's going to go down. Something that I like to remind myself of, if I have an odd graph, then the ends should always act opposite of each other. So if you have x to the 3rd, x to the 5th, x to the 7th, like those kind of exponents, your graph, because it's odd, eventually the ends are going to be different. One's going to be going up and one's going to be going down. If it's even, they're always going to end the same way. They're always both going to be up or they're both going to be down. I think even ones are a little bit easier to identify because if you think about what we even talked about yesterday with those parabolas, an x squared, that's an even function. So when we talked about parabolas, they were either opening up or they were opening down, right? Because the end behavior is the same on both sides. And so when you think about what made it open up or down, well, that's when we looked at that leading number. Was it even or was it odd? That tells you whether it goes up or down. So when I'm looking at an even function, that very first number is going to tell you if it's going to go up or down. If it goes up, like if it opens up, then you know that the ends are going to go up forever. If it's negative, you know it's going to open down eventually. The odds are a little bit different because they're obviously going to be facing different directions. But when it's positive, that means that eventually when you end the graph, it's going to start going up. Positive, again, means you're going up eventually, and so the other side would have to act different. And if it was a negative graph, then when it's going to end, it's going to eventually go down forever, and so then you would start by going up forever. Those are some things that I've just kind of gathered as I've done a lot of practice with this. Maybe as you guys start doing some, you'll start to recognize some patterns or relationships that help you know what the end behavior is going to look like. Down below, there is a graph here that kind of gives you some pictures of what I was talking about. And these are just kind of different polynomials, some, that do cross the x-axis and some that don't. So we can kind of see all those different situations, but it's kind of showing you what I highlighted up above, what an example of a graph might look like. They're not all going to look exactly like these. All graphs look a little bit different from each other. So if you're ever really in doubt of maybe what to do, I would come back and look at this. The other thing I want to add right next to this area up here that we kind of highlighted all that stuff, I'm going to make a little chart. So I'm going to write odd n and even n. And then over here, I'm going to say that my leading term, I'm going to say is greater than 0 to represent that it's positive. And then I'm also going to say A sub n, that's your leading term again, less than 0, that would recognize that it's negative. And then inside the chart here, I'm just going to draw a couple arrows that describe what would be happening with my end behavior. So if it's an odd degree and your first term is positive, that's like the yellow case that I highlighted over here. That means that the left side of the graph would end down and the right side of the graph would end up. Directly underneath that, if it's still odd, but this time your degree is negative, those arrows are going to flip directions. So it's going to start by going up. It's going to end by going down. So the first arrow represents what's happening on the left. The second arrow represents what's happening on the right side of your graph. If it's even and your first degree is positive, they're both going to go up forever. So the left goes up and the right goes up. And then if we are even still, but negative now, they're both going to go down. Left goes down, right goes down. That might be something, especially as we get going like towards getting ready for quizzes and tests, you'll get a note card for those as well. That'd be a really easy thing to put on your note card. And it kind of summarizes this big idea of that end behavior. It might just be a little reminder of what's going to be going on. All right, so that was a lot of information to kind of go over at one time. And it's just like a lot of words. So like, how do we actually use this? So if you guys turn your page over, we're going to do some examples. And we are going to be graphing, okay, which is why I asked you guys to grab a table, because we're going to use our tables to try to help us find some good points that we could maybe just put on our graph without having to think too hard about this. The first thing, though, that I'm going to do is just figure out what is this going to look like as far as end behavior goes. So I want to look at this first one. And my leading coefficient would be that number 3, which is in the wavefront. Okay, so I'm focused on this 3 right now, and I'm focused on this 5. So my leading coefficient is positive. So I'm just going to write it's positive. But the 5 means that it's odd. So this is a positive and an odd graph. Again, if you need to, you can just kind of flip back and look at that little table that we just kind of created. I'll just scroll back up to that. So we're talking about positive and odd, which would be this situation right here. The graph is going to start out by coming up from negative infinity, and then eventually it's going to go up to positive infinity forever. So I'm just going to kind of draw that. It's going to start by going down. It's going to start by going up. Okay, now words-wise, like if they wanted you to actually explicitly state out what is this end behavior doing, we'd be talking about as my x values start to approach infinity. So as my x's go farther to the right, then my graph, f of x, is going to go up forever. And if my x is going towards negative infinity, so if I'm going to the left, then the graph is going to start going down as well. You may have had to write end behavior like that last year in Algebra 2, where you were describing what was going on with the x and the y values on your graph. Yeah. Now, this at least tells me, like I have a 5 here. So the most number of times that it could cross my y-axis or my x-axis is 5. Okay, now don't graph what I'm going to graph here. I'm just showing you what could possibly be happening. I can recognize if it's got 5, that means there's at least or at most 5 zeros that I could potentially find. And I know it's going to start by coming down. So anytime it crosses the x would be counted as like a 0. So it could look like this. 1, 2, 3, 4, 5. Now, I'm not saying that this is what this one's going to look like. Okay? But this is what like the most it could look like as far as how many times it crosses the x-axis. But this at least gives you an idea. The left side should always be going down. And the right side should always be going up once we get there. What we need to do, though, is actually find real points that we can put on our table here to get the graph in. And that's when your table is going to come in handy. So I hope all of you have a calculator. Yeah? So hit your table. And then let's type in this equation. 3x to the 5th power plus x squared minus 1. I should probably grab one too. Make sure too when you're typing it in, arrow out of your exponent, or it's going to type all of the rest of the equation into the exponent area, and that's not going to be right. Okay. It doesn't really matter where we start because that's going to just depend on where you're at on the graph, and you just have to find some nice points to put on there. So if you can't fit it on your graph, then you probably don't want to use that point. Okay. See, I even had mine start at 8, and those numbers are huge. Do yours get pretty big pretty fast?
Yeah.
Okay, so like what's an easy point that we can graph that you see? What'd you say? 0, -1. What's another easy point? -1, -3, right? Oh, and there's 1, 3. Okay. And then they start to get really big, right?
Mm-hmm.
So when I start to see really large numbers, that's telling me that's going to be like the end of your graph because they're going to start to go up exponentially fast. Like if I'm going towards the negatives here, like -2, -3, -4, they're starting to get really large. Like -4 is at -3,000. There's no way I'm graphing that. Okay. But that tells you kind of what we talked about with our end behavior. It is going to start to go down forever. And if I go to the right and I start going to my positive numbers, +4, +5, +6, and so on, that starts to get really large too. So now that I have at least these points kind of on my graph for me, I can connect them and know that the right side of my graph, like when I'm connecting that top dot to the next one, it's going to go up forever like this, and then it's going to come down forever like this. Because then if you look at those arrows that we started out with here, it should match what we said. The left side is going down and the right side is going up. Now, does that actually look like the one that I said it could look like? Remember how I drew that first one in with all the ups and downs? It doesn't look like that one really at all, but that's because probably some of these zeros are repeating themselves. Or maybe there isn't 5. Maybe there's only less than that are actually showing up. Okay, so let's do another one. Let's start out by describing end behavior. So is this a positive or a negative graph? And is it even or odd? Okay, so it's negative and it's even. That means it's going to behave the same on both sides of the graph because it's even. Are they going to go up or down forever? Down, because it's negative. So I'm just going to draw those arrows. And then again, I will write out, this means as x goes to positive infinity, the graph is going to eventually go down forever to negative infinity. And as x goes to negative infinity, that means that your y is going to eventually go down as well, because they're both going down. Now my degree of this is 4, so that means it could cross my x-axis 4 times, potentially. It may not, though, but it should at least cross the x-axis an even number of times. So even if it doesn't cross 4, it could cross 4 times or it could cross 2 times. It should not be crossing my x-axis 3 times or just once, because then it would be an odd graph and it wouldn't make sense with what we've said so far. So let's go to our table this time and let's get some points that we can graph here. Again, those numbers start to get pretty big pretty fast. I think the center point is 0, 7. Do you guys agree?
Yeah.
And then it's 1, 8 and -1, 8. So it kind of just goes up a little bit. And what other point do you think maybe we could fit on here? We could probably do that -13. I mean, it's going to go off a little bit, but -2 is going to be down here at -13, so it's going to go way down. And +2 does the same thing.
Were those supposed to be a -8 or +8?
I have +8 on mine.
Yeah.
Do you have +8?
Yeah.
For your y? Is that not what I did?
No, that might be right. I just thought you said negative.
Oh, I'm sorry. +8. Okay. And now I'm just going to connect this. because you can see those points are going to start to get really big. So this is kind of going to almost look like the letter M. It's just going to be really narrow here at the top. But eventually it's going to connect and it's going to go way down. Like that. Does that graph cross the x-axis an even number of times?
Yeah.
Yeah, it only crosses how many times though? 2, which means wherever it crosses, and I'm not looking for that right now. I'm not looking for solutions at the moment. Wherever it crosses, those answers are potentially repeated because of where they are, okay? Do you have questions on how I'm doing that? Okay. We're going to start continuing to do this, like describe end behavior so we know what they look like, but we're now going to also start to, if we can, factor to actually figure out where does it cross the x-axis at, because we're going to start looking for actual roots that we can use. So I'm not really going to change much about what we just did up above. I'm going to do all that same thing. But now I'm also going to be looking to see, can I factor this and can I actually find x-intercepts? Those would also show up on your table if they were there, because they're going to cross the x-axis. That would be anytime that you see a 0 in your y column, that would be a solution, or they might call it a 0 or root to your equation. Okay, so first of all, let's talk about end behavior. Is this graph positive or negative? And is it even or odd? Okay, that means they're going to behave differently, but because it's positive, the end of the graph is going to be going up. So the left side has to be going down, the right side is going to be going up. Okay, now let's take a look at this equation. Do you guys remember what we have to do to factor something with 4 terms? Parentheses, you have to group. Good job. So you're going to group the first 2, group the last 2. What can we take out of that first pairing?
X squared,
And what would be left?
X plus 2,
What can we take out of the second set?
-4.
And that should leave you with x plus 2. Again, when we factored yesterday, we talked about this. Like, you know you did it right if your parentheses match, so you're good to go. So we have x squared minus 4, and we're going to set that equal to 0. And then we have x plus 2 equals 4. We're going to set that equal to 0. This is going to help us get a couple of points that we can just put on our graph. If you were to solve the x squared minus 4 equals 0, what would you do?
Add the breaking down.
You'd what?
X plus 2.
Oh, you could do that. You want to factor it even more? I mean, that's great if you can recognize that, because that is one of those special cases. What were you going to say, Tanner?
I was just going to add 4 and square root.
Yeah, that would be another way you could get that. You're going to get the same answer as him.
Yeah.
You could add 4 and square root it. You're still going to get what 2 answers? Positive and negative 2. Over here, when we solve this side, what are we going to get? Negative 2. Do you guys see how negative 2 showed up twice? So when you graph it, you're not going to be able to graph that point twice because it's just going to be on top of itself. But this would be something called multiplicity. Multiplicity just means a root gets repeated. You don't have to write that right now. Eventually, we'll maybe start talking about writing those out. But these are my x-intercepts that I could put on my graph. So coming over here, I'm going to put a point at negative 2 and at positive 2. The only thing I might do is go to my table now and see if there's maybe any other points that would be easy for me to graph. If not, then I'm going to try to just graph it with what I've got. But I'm going to type this in. So x to the third plus 2x squared minus 4x minus 8. I see a couple of points that we could maybe add on if we want to add a little bit more detail here. And it'll also help you kind of catch the overall shape of this graph. So negative 4 is really big, but if we go to negative 3, I've got negative 5. So I'm going to go ahead and add that point. And then we saw negative 2, 0. We already found that one because that was our intercept. Then we have negative 1, negative 3. 0 is at -8. 1 is at -9. And then we have 2, 0, which is our other intercept that we already found. And then 3 is at 25, so it starts to get really big. But if you kind of look, right now it looks like a bunch of dots, okay? But what we're going to do is connect these to make our graph. Remember what we said about end behavior? The left side of the graph should go down forever. So when I'm up here at 2, -2 on my x-axis, and I'm trying to connect to that -3, -5 point, it's going to go down forever in this direction. So I'm going to go ahead and continue to have it go down, draw an arrow. This other side is going to maybe just come through and hit these points, and then it's going to turn and go back up. Again, it could be crossing. We found the 3 times that it crossed. It's just one of them gets repeated. So this is 1, 2, 3 times that it crosses. This one is that multiplicity that we talked about. So it is crossing an odd number of times. It just appears like it's crossing an even number because of that repeated factor. Questions on how I did that one? Okay, let's do another one. Yes. Okay, positive or negative? And even or odd? Good. So this is the exact same case that we just talked about. So it's going to look like that for end behavior. Okay, let's see if we can factor this. We're still dealing with 4 terms. Whoops. 3x squared. And then let's group. What do you guys want to take out of the first set? And out of the second set? -2. Yeah, I would take a -2 out. That way it becomes positive 2x minus 3. Okay, we're setting these equal to 0 now. Now this one, it's similar to the last one we did, but you can't factor x squared minus 2 because that's not a perfect square. So you will probably have to do where you add the 2 over and square root it. Now you're going to get not nice numbers there because this is going to come out to be plus or minus the square root of 2. But if we wanted to kind of estimate where we think those are at, we could find the decimal of that because I think we did that yesterday. The square root of 2 was like 1 point something, 4. So if you really wanted to include those points on there, they'd be about there. What would this one come out to be over here? 3 over 2. What is that as a decimal? 1.5, right? Mm-hmm. So if you wanted to include those points, you could. That would be about where they are on the x-axis. It's going to be kind of hard to squeeze that 1.4 in there because it's going to look like it's right on top of 1.5. Because it's going to be right next to it. I try to get them in there side by side. Okay, now let's look for some other points. Can you guys type that into your table? Tell me some points I should add on.
6 and 0. 1 and 1, 2 and 2.
Okay. 0, 6 you said first, right?
Yeah.
And then
1 and 1.
1, 1.
2 and 2. Negative 1 and 5.
Okay.
Negative 2 and 14, I guess. Negative 14.
Negative 14, so it's going to come down here. Okay. Is about all we can fit?
Yeah.
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 Yeah. Okay. But But this allows me to kind of see what's going on. So remember, on the left side, this graph is going to go down, which it appears to start doing. And then it's going to come around this other way. Again, that one, it's a little bit easier to maybe see the 3 separate times that it does hit that x-axis. There'd be like a little bit of movement that maybe has it go down in between 1.4 and 1.5. It's hard for me to show that up here just because it's so small. If we put this equation like on Desmos or something, we'd probably be able to see like it would dip a little bit below that x-axis, and it would show you that it is crossing an odd number of times, and it would match what we said. Any questions on that? Okay, I think that's where we're going to pause for today because we only have a couple minutes left.